Hello friends, today we are guiding you to prepare interview questions on Python. In comments you can share the topic of your interest. Our team will prepare the video for you. Before continue to our session, we request you to join our channel for all the latest updates. Our team of technical and subject matter experts are working hard to create valuable content just for you. So please make sure to hit the subscribe button, like and comment on our videos, and click the bell icon to stay updated with our latest videos. What is the difference between threading and multiprocessing in Python? In Python, threading and multiprocessing are two approaches for achieving concurrent execution, but they differ in how they manage tasks and system resources. Threading uses multiple threads within a single process. All threads share the same memory space, making it lightweight and efficient for I/O-bound tasks like reading files, making network requests, or waiting for user input. However, due to Python's Global Interpreter Lock (GIL), only one thread executes Python bytecode at a time, limiting its usefulness for CPU-bound tasks. For example, import threading def task, print thread running t equals threading.thread target equals task t.start. Multiprocessing, on the other hand, uses multiple processes, each with its own Python interpreter and memory space. This bypasses the GIL, making it ideal for CPU-bound tasks like computations and data processing. However, it consumes more memory and has a higher overhead due to process creation and inter-process communication. For example, import multiprocessing def task, print process running p equals multiprocessing.process target equals task p.start. In summary, threading is best for I/O-bound operations due to low overhead, while multiprocessing is preferred for CPU-bound tasks that require true parallelism by utilizing multiple CPU cores. What is the Global Interpreter Lock (GIL), and how does it affect multithreading? The Global Interpreter Lock (GIL) is a mutex in Python that restricts the execution of multiple threads in a program. While Python allows the creation of multiple threads within a program, the GIL ensures that only one thread executes Python bytecode at a time. This means that even if a Python program uses multiple threads, only one thread can execute Python code at any given moment. The primary effect of the GIL is that it limits the effectiveness of multithreading for CPU-bound tasks in Python. Despite the use of multiple threads, only one thread can be actively executing Python code at a time due to the GIL, causing performance bottlenecks in CPU-heavy operations like data processing, mathematical computations, or image manipulation. However, the GIL does not prevent I/O-bound operations, such as network requests or file reading, from running concurrently. This is because I/O operations release the GIL while waiting for responses, allowing other threads to run in the meantime. To achieve true parallelism for CPU-bound tasks in Python, multiprocessing, using multiple processes instead of threads, is often used. This approach avoids the GIL by creating separate processes with independent memory spaces, allowing Python to fully utilize multiple CPU cores. How do you create a thread in Python? In Python, creating a thread is done using the threading module. A thread is essentially a separate flow of execution, allowing you to run multiple tasks concurrently within the same program. To create and run a thread, you need to follow these steps. Import the threading module. First, you need to import the threading module, which provides the tools to work with threads. Define the target function. Create a function that will be executed by the thread. This function will hold the code that the thread will run. Create a thread. Use the thread class from the threading module to create a thread object. You can specify the target function that the thread will run. Start the thread. Use the start method to begin the thread's execution. For example, import threading def print_hello, print hello from the thread. Create a thread t equals threading.thread target equals print_hello start the thread t.start wait for the thread to complete join. In this example, the print_hello function is executed by the thread. The start method initiates the thread, and join ensures the main program waits for the thread to finish before proceeding. This is useful for synchronizing threads in multi-threaded applications. What is the threading module used for? The threading module in Python is used to create and manage threads in a program, enabling concurrent execution of tasks. Threads allow multiple parts of a program to run simultaneously, making it possible to perform I/O-bound operations, like file handling, network requests, or database queries, without blocking the main program. Key uses of the threading module include concurrency. The module allows multiple threads to run at the same time, improving efficiency for tasks that are I/O-bound, such as downloading files or interacting with external APIs, where waiting for one operation to complete can slow down the entire program. Parallelism. Although Python's Global Interpreter Lock (GIL) limits true parallel execution for CPU-bound tasks, threading can still be useful for certain tasks where multiple threads handle different operations, like serving multiple client requests in a web server. Synchronization. The threading module provides mechanisms like lock, event, and semaphore to coordinate the execution of threads, ensuring that resources are accessed safely and without conflicts. Thread management. It offers features to create, start, and manage threads, and allows for graceful thread termination with methods like join to wait for threads to finish. In short, the threading module is essential for writing concurrent programs in Python, especially for I/O-bound tasks. When should you use multiprocessing instead of multithreading? You should use multiprocessing instead of multithreading in Python when dealing with CPU-bound tasks that require true parallelism. The key difference lies in how they handle concurrency. CPU-bound tasks. These tasks, such as heavy computations, data processing, or mathematical operations, involve intensive CPU usage. Python's Global Interpreter Lock (GIL) limits the execution of multiple threads by allowing only one thread to execute Python bytecode at a time. This prevents true parallelism with multithreading. Multiprocessing avoids the GIL by using multiple processes, each with its own memory space and Python interpreter, allowing true parallel execution on multiple CPU cores. I/O-bound tasks. If your task involves waiting for external resources, like reading files, database queries, or making network requests, multithreading is more appropriate. In this case, threads can run concurrently while waiting for I/O operations to complete, allowing the program to continue executing other threads. In summary, use multiprocessing when you need to perform heavy computation and take advantage of multiple CPU cores, ensuring true parallelism. Use multithreading for tasks that spend most of their time waiting for I/O operations, where concurrency can be achieved with low memory overhead. Thanks for watching the video till the end. If you liked the video and haven't subscribed yet, please hit subscribe button, like and comment on our videos, and click the bell icon to stay updated with our latest videos. In comments you can share the topic of your interest. Our team will prepare the video for you.